The next example we're going to look at is a potential piece of malicious software. So again, to look in that directory, we see this file right here. It appears to be a 64-bit Linux executable, dynamically linked, and this one's stripped. And this is why you might not necessarily want to use something like GDB to debug something like this. I'll show you why. Again, just out of the box, it's not the best tool. If I say GDB and I load up this executable, and I say info functions, so show me the functions inside this program. There are some interesting functions. I mean, we can see some stuff in there. Even though this is a stripped executable, it didn't necessarily have the names of the imported functions stripped. We don't see a main in here because main, along with any other local functions, would have been stripped out. We can determine some stuff. I mean, we see a call to, there's printf, there's some string comparison, there's some socket calls, maybe some networking stuff. Here, and these are the libcurl library, so maybe we're fetching some documents from the internet. This one's interesting. popen is for opening a subprocess in C. So maybe this thing spawns subprocesses. There's a sleep, a memcopy, some stir copies. There's a call to exit. Some more low-level network stuff. So we can kind of understand a little bit of what's going on, but again, we don't see a main. There are ways you could figure this out in GDB if you had to. For example, you can say something like start I, which will start the program at the first instruction, and it will sort of break at the first instruction in the code. And then you could kind of walk through it until you find main or something like that. But again, this is not well suited to doing this out of the box without any extra add-ons. So what we can do is load this in Radar. Again, we're going to throw the -d switch so that we start in debug mode, and then the name of our executable. Okay. Again, I will tell Radar to run the standard set of analysis on it. Okay. And then if I run AFL again to list the functions, again, we see the functions we just saw in GDB, right? Some of the imported stuff, but we also see down here a main. That was helpful. It was able to sort of parse that out for us. So if we seek to main, you'll notice the address here, which is probably the entry point, will update to be the first address of main. Cool, so now we're in main. We can confirm that by printing the disassembly for that function, so PDF for the function we're currently sitting at. And so there's the code for main. Now, this is not a great mode for debugging in, sort of this command line terminal version, so we're going to look at some of the GUI versions of Radar. This time, instead of sort of just stepping through the program, waiting for things to happen, we're going to take a slightly different approach. We're going to do something that we all tend to do when we're doing static analysis. We're going to take a look at all the strings first. So if I say IZ, it's going to show me all the strings, or at least what it thinks are strings out of the read-only data and data segments. So we see some stuff in here that makes sense, some of it not so much. Like we see Mac with a semicolon, yeah, that could be a thing. Malicious.jpg. Some stuff over here, which, I mean, since it's all in ASCII and in the data section, maybe these are strings, maybe they're encrypted or encoded in some way. We can look at that in a little bit. There's also this one up here. The only time the string analysis isn't perfect, you'll notice everything else has been encoded as ASCII. This is UTF-16. Maybe there was some like character encoding mix-ups. It's also interesting because the next string we see is -a-o command. Those look like switches to a command. We also saw when we ran AFL that this thing has a call to popen. So that typically as an argument takes a string of the command you want to run on the system. So this potentially looked like part of that command. It could be that the preceding part of this, the actual program that's being run, kind of got misencoded here or misunderstood by Radar. So what we can do is backtrack a little bit and try to print characters just before this one. So we won't do that. So with Radar, if we want to print text at a location or data at a location, there is a sort of formatted print command. So just to test, we're going to see if we can print this string from that address. So print a formatted piece of text. Now there's a lot of different format specifiers that Radar supports, like digits or decimals. One that you're probably going to use if you're dealing with strings, though, is a lowercase z. This says print the contents at the memory address I'm about to give you, and assume that it's a null terminated string. That's basically what it means. We can also put like brackets that say, you know, print me 5 bytes, treat it as a null terminated string, starting at memory address, this one. Okay, so you'll see we got like 1, 2, 3, 4, 5 characters from this. Right, so I could just say print that whole thing up until you hit a null termination. Right, so there's that. Now if we think that before this string, maybe a few characters back here, we actually had the original part of this command, what we can do is say, I don't know, print me like 20 characters, and we'll just subtract a little bit from this value, maybe say from like 1, 5. Interesting, we see a PS, an IN, a slash. That's starting to look like a command if we go back a little bit further. Nope, maybe too far. There we go. So we actually see /bin/ps. Okay, the ps command, AO command, and we didn't quite print enough characters to get to full thing. If we wanted to see the whole string, you know, print me 21 characters as a null terminated string starting at this address. And so there's the actual string that lives there. That's useful for us. We know that there is a call to popen in this program. This is a call to, you know, the process list command in Linux. So all/all and then -o controls the formatting and output for PS, basically allowing us to specify which columns we want to see. So this is actually running the process list for all and only showing the actual command that was executed to run that process. It's a really handy version of the PS command if you basically just want to get the names of the programs, or if you want to call it like the name of the process that's being run. So that's interesting. So this thing is doing a search for currently executing processes. The next thing we might want to do is to look at where some of these strings are being used. So the term is where they're being referenced or cross-referenced. Sometimes you'll see it abbreviated in documentation as Xref. So we can kind of guess that this is going to be used somewhere where that popen command is. There's malicious.jpg, which sounds kind of interesting. There's also these, which I hinted might be encoded or encrypted in some way. So one thing we could do is actually see, you know, where is this string being used in the code? So a way we can do that is we can grab this memory address and we can say, basically show me any cross references, that's what this means, starting at, you know, sort of this memory address. It basically says, trying to show me locations, you know, where this address might be referenced in code. It'll take a few seconds to run because it basically searches for references to this address throughout the code base, assuming some things too, like see here, it appears to be referencing these addresses as instruction pointer plus some offset from there. So that's the location in code where it's being referenced. This is the location in code where it's being referenced, the actual instruction. You will also get things that are pointing to the general area of the variable you specified, because maybe you specified like the middle of a struct as the thing you were looking for, right? And so maybe that exact address won't be referenced, but it'll be somewhere close. So I know from playing around with this previously that these first two are not direct references to this address, but they point to some of the other strings in this area. This one, though, is an actual direct reference right to the address. So if I grab this, this is the location in the text segment or where the code is referencing this variable, okay? So we're going to copy this. I'm going to say seek to that location. Now we can pull up our assembly view by saying capital V, and here's our code view where the line it will position you at. This is the line that we searched for, or that we seek to. It'll position us right here, and this is apparently where that value is being referenced. So we see here stir.evsver. It's actually saying, hey, off in the data segment you had this string called this, and it kind of created like a label there for us called evsver. So this is where that string is actually being used or referenced. What's kind of interesting down here, just a few instructions later, we see a call to stir, which is like the substring search. So maybe we're searching for this somewhere in here. Now, unfortunately, this doesn't look like it's actually decrypting it. Here we're actually like using the instruction. If we scroll up a little bit, maybe we'll see something else. Oh, there's the call to popen with that bin ps -ao. That's interesting. So in proximity, we're calling, this process to list all the processes. And then right here, we're pulling in that string from memory, and then we're doing a substring search. So it could mean that we're looking for whatever this string is going to be when it's decoded in the process list. Maybe. We're just sort of guessing. Right? If I go up a little further, here's another reference to that string and a call to a function right before that. Interesting. And then up here's the top of this function. You'll notice here Radar doesn't insert any comments for us, letting us know that we're inside of a function, but we know it's a function because this is our standard function prologue. The instruction right before that was a return statement, and there don't seem to be any jumps pointing to this spot from up above. So that was probably the end of a previous function, and now we're in a new one. If we wanted to, we could actually define a function here. It's useful to define functions when you find them, because if I hit capital V right now to bring up the graph view, Radar is like, oh, this isn't a function, so I can't draw you a graph. So if I hit DF for define function, it's going to say, hey, what's your function name? I don't know. We don't really know what this is doing yet, so we're going to say string use, because this is where our string is getting used. I don't know. So it's put like a name or a label on this, but we haven't treated it like a function yet. We haven't told the engine to go and analyze this as a function. So you can actually say analyze function at string use was the name we gave it. Okay. Now you'll see it's actually treating it like a function. There was the old return statement. String use, it's maybe located some variables on the stack, stuff like that. And then we're still at that location. And then down here, we have our reference to our variable that we're interested in. We have some function call here, the call to popen, our variable again, and then a substring compare. So maybe there's something interesting going on here that we could analyze and figure out. Okay. Now that we sort of have this marked as a function. Also, now that we've defined a function here, if I hit capital V again, we can actually see the function graph. It will have started the function here and actually can draw this graph for us, which is actually appears to be be like a non-trivial operation. If I zoom out a little bit, right? So we have this jump down into here. With maybe some like loop setup, and then we're doing something with our string in here by calling this function, and we're looping back up to here. So there's some sort of loop going here that's doing processing on our string maybe, based on this function call. And when eventually something evaluates to false, we're going to dump down here and do our process open. Interesting. So maybe since we're taking the string and I don't know, doing something here and looping over it, maybe this is some kind of a decrypt or decode operation. Something else that's interesting and noteworthy. Right here, we're loading the address of the string into DX, and then we're actually adding DX to whatever's in AX, and then moving that into the destination index register and calling this function. So it's almost like we're incrementing on this string a little bit, and we're doing that by shifting and then adding. Interesting. So kind of like the value in AX is growing as we sort of iterate across this. So we could be iterating over this string. It could also be like an array index operation, because Radar is not great at showing us by default like string arrays and things like that. So we could kind of dig into that a little bit before we go and figure out what's going on right here. If I hit Q, it'll bring me out of visual mode. Okay. So we know from running an IZ that our string sort of like lived right here. There's another one of these funky looking encoded strings right after it. There are some more before, but if this was some kind of string array reference, it's pointing to this location first. So that might be the first element in that string array, if it is one. Okay. Other things we can dig into. So if we do think that this is some sort of decode function, we can actually just hop over to that function and see what's going on. So this call 6A8. So if we move down here, if I hit enter, it'll go into this function. So now we're in here where our string is being passed into. We can also see this function's being referenced from both the main function and from our string use function we just defined, which is interesting. We might as well stop and define a function here. df, give it a name. we're guessing that it's doing some decode. I mean, maybe the fact that there's an XOR happening right here is suggestive of that. So I don't know, we can call it decode. And then we're going to analyze the function decode. We're going to treat it like a function here. So if I bring up the graph view again, here's our decode function. We can see that there's a loop right here before we eventually return. What are we doing in the loop? We're checking the length of something, and then we're doing a loop with an XOR in it. Yeah, that might be decryption or decoding of a variable in some way. We're not totally sure, but yeah. So if we figured out that maybe that's some kind of decrypt, we can hop back to our string use function just by bringing up our little console by typing the semicolon, or the colon, sorry, and saying seek to string use. And now we're back where we saw our string being used. If we want to know maybe where this is in the sort of broader scope of the program, we could always seek to main and view this. We don't see it here, although we do see, recall that main called that decode function once, so that's kind of interesting. We see that call there. But we don't see this string use function being called directly, so it's probably a sub-function being called by one of these other guys. So we'll exit out of that. We'll seek to our string use function for a second. So it's there. So we're in our string use function. Again, just kind of to recap, we started out this debugging process by examining some of the strings, right, that might be in this executable, looking for references to them or Xrefs, and then sort of backtracing maybe where this string was getting used into maybe something that was like a decrypt function or a decode function, as well as in this function that we called string use, where we see, you know, it being pulled in and maybe decrypted or decoded, and then we kind of go on and maybe use the output of this in some kind of operation along with the output of this popen command that's being used. So the next thing that maybe we might want to do to backtrace from all this is actually find some references to string use, right? Like we want to know where this thing is being called from. You know, just to kind of explore the program. You might not always necessarily debug a program this way, but it's the route that we've chosen. I also wrote the program, so I kind of know what's in it. So one of the things we could do is run a flag search like we did originally, right? When we had our strings, we looked for all instances of code, maybe referencing this memory location or pulling this string. But there's actually a shorter version we can use, or a bit of a shortcut. So since we've already defined string use as a function itself, we can rerun the function and high-level analysis inside Radar that we ran when we first started our debug session. So if I hit colon to bring up the prompt and just hit 3 A's again, it's going to do some analysis on that. We hit enter again to get rid of our prompt. And look at that. Up at the top of this function, the analysis actually found a reference to string use from main, right? So we can pop over to main and find out where this call is coming from. So we see it's actually at main plus OX75. We can even get there right away by saying seek to main plus OX75. Like it's an offset from main that we're jumping to. Okay. So now we're down here. You actually see the call to string use. This is an offset of 75 bytes, or 75 in hex, away from main. If we scroll up to where main is, we should be able to see it right here. So there's main, right? But there's a bit of a problem. If we scroll down to where our reference was, we actually see that it was down here. And look what's a few lines earlier. There's actually this function prologue right here. So we actually think maybe it's another function that Radar missed. That's why it just sees it as an offset from main, because it's so many bytes down from main itself. So we can actually just define another function here, even though we're not entirely sure what it is, but it is calling this string use function. Right? So again, we can define that function by popping into the graph mode really quickly. Graph mode says, hey, there's no function here. So we hit df to define a function. We don't really know what this thing does yet, though. We just know it's maybe some sub-function or sub-process within main. So as far as a name goes, I'm just going to call it like main sub-function 1. Maybe when we learn a bit more about it, we can change its name. So I'm going to call it that. And then we can say analyze function, MSF1. Okay. So we see that it is a function, and it's getting called from main. It's actually being called directly from main. So if we actually scroll up to main, now that's populated that function call with our call to this sub function. So we know that somehow main starts off, and actually the first function it calls is this sub function down here that then eventually calls that string use function that we saw where our string was being decrypted. A little bit before that though, inside this sub function, there's this call right here. So we could delve into that and explore that a little bit. At this point though, I want to start debugging, or actually stepping through the program a little bit, just so that we can start to get a feel for really what's going on here.